Hi, everybody. This is Miss McClellan here to go over our practice checkpoint 4.2 with you. So in this checkpoint, we will be covering finding missing sides of a triangle. When it's a right triangle and you're given one of the angles and one of the side lengths, finding angles. When you're given two side lengths and a right triangle, a story problem that can be solved with trigonometry. And the last problem, which is where you need to be able to figure out what x equals when you're told that cosine of an angle is equal to sine of an angle, and each angle is written in terms of x. Okay, first problem. So this problem says find x using this diagram. So the first thing I see is that I have 40-degree angle triangle. The adjacent side length is 7 and the opposite side length is x, and I need to find x. Well, tan of 40 degrees, if I use SOHCAHTOA, and tan gives me that I will be using opposite over hypotenuse over adjacent. So tan of that 40 degrees is equal to 7 over y. Just kidding. X over 7, sorry. And then I cross multiply to solve for x. I have 7 times tan of 40 is equal to x times 1, which is just x. And the answer becomes 7 times tan of 40. And I'll do that on my calculator right now. And x is about equal to 5.8737. Okay, now we're going to find y. Now for y, I'll use my adjacent side and my hypotenuse. When I'm using adjacent and hypotenuse, that's cosine. So cosine of my 40-degree angle should be equal to the ratio of 7 over y. I cross multiply, I get y times cosine of 40 equals 7 times 1, which is just 7. And y is not alone yet, so I need to divide both sides by cosine of 40. Then I have y is equal to 7 divided by cosine of 40, and I'll do that right now. 7 divided by cosine of 40 degrees gets me that y is equal to 9.1379. Okay, next problem. This problem says find the angle using triangles. The triangles below, round to the nearest degree. So I'll be finding for this one, angle A, for this one, angle B, for this one, angle C. First of all, I see with angle C that it's the right angle, so 90 degrees for angle C, done. A and B take a little bit more work. So for angle A, I will use cosine because 3 is adjacent to A and 5 is the hypotenuse. And cosine uses adjacent and hypotenuse. So I have cosine of angle A is equal to 3/5. And in order to find the angle itself, I need to use inverse cosine. So inverse cosine of 3 over 5 is equal to angle A, and I'll put that in my calculator. And I get 53.1301 degrees. Okay, next problem. Next problem is to find angle B. Now, I could use the triangle sum theorem and subtract both 90 and 53.1301 from 180, but I actually think that using trig is easier. When dealing with angle B as my reference angle, 3 is now the opposite side, because 3 is the length opposite of angle B, and 5 is still the hypotenuse. Okay, this will be sine because sine deals with opposite and hypotenuse. Sine of angle B should be equal to 3/5. I'll use inverse sine. -1 of 3/5 is equal to, let's put that in the calculator. Sine 3/5, 36.8699. And just to make sure my answers make sense, I'll add all of these angles together and make sure they equal about 180 degrees. So I'm going to add to this angle, hold on, to this angle, I will add 53.1301 and 90. And that does get me 180. This is 179.9999, basically 180. It's just a little rounding error. Okay, number 3. This is a story problem. A ladder is 40 feet long and it's leaning on a wall. Okay, so I've got a 40-foot long ladder leaning on a wall. The base of the ladder touches the ground. That's right here, at a point 30 feet from the wall. So this distance is 30 feet. I have a right triangle because buildings are generally perpendicular to the ground. Find the angle that the ladder makes with the ground. So that's this angle right here. Okay. This is opposite, this is adjacent, and this is hypotenuse. I'll be dealing with the hypotenuse, the adjacent, and my reference angle. So that's going to be cosine. I have cosine of my angle equals 30/40. To find the angle itself, I'll need to use inverse cosine. So cosine -1, inverse cosine of 30/40 should equal my angle. And I'll put that in my calculator. And I have, my angle is about 41.4 degrees. Okay, last problem. Find an angle measure x such that cosine of 3x equals sine of 6x. Okay. Well, I know if cosine is equal to sine, let me just draw a triangle. I'll name this A and B, and I'll name this A, C. So in my little diagram, angle B is the angle across from the hypotenuse, angle A is across from A, and angle C is across from C. Now, suppose that angle A equals 3x. Then cosine of A equals C/B, because that's adjacent over opposite. And in which case, sine of C would also equal C/B, and that would be angle C, and I'm going to let that be 6x. What I know about angles A and C is that they equal 90 degrees. So if cosine A and cosine C are equal, and they are, it's C/B for both of them. No, sorry, this should be lowercase. Then the angles must be complementary, meaning they add to 90 degrees. So I've got cosine of 3x equals sine of 6x. That tells me that 3x plus 6x is equal to 90. So 9x equals 90. Divide both sides by 9, and you get x is 10. The measure of angle x must be 10 degrees. And I know because when sine and cosine are equivalent, their angles are complementary, meaning they add to 90 degrees, period. Okay, so that's it for the practice test. I hope you all do well on your exam, and I'll see you next time. Bye.